The total time of flight and the range of a projectile launched on an incline have been computed by us in the previous lessons. Now we want to compute the maximum height. So what is this maximum height that we are talking about? Is it point B, the maximum height from the ground, which is the highest point in the trajectory? No. This is not the point that we wish to compute the height of. If in any case we wanted to compute that, then we would have applied the earlier formula when the projectile landed back on the ground, and that would be v0 squared sine squared theta over 2g. But this would be with respect to the ground. What we are interested in now is to compute the maximum height of the projectile with respect to the plane of the incline. So this is the maximum displacement from a man standing on the incline as he sees it. And these 2 points are indeed different. This point B is the highest point in the trajectory with respect to the ground, whereas this point A is the highest point with respect to the plane of the incline, and this is the height h which we will attempt to compute. And in this lesson we want to build the foundation to compute h. First of all, how do we get to point A? If we draw a tangent to this parabolic path parallel to the incline, then we would get point A. And a few things are noticeable right away. A is the point which has the maximum displacement from the plane of the incline. If you observe the trajectory from the launch point to point A, and then from A to the landing point, then the 2 halves of the trajectory are not symmetric. Whereas when we launched a projectile from the ground and it landed back on the ground, the trajectories were symmetric about the highest point. And if you compare the ranges from the launch point to the midpoint and then from the midpoint to the landing point, it seems quite obvious that they are not equal. But there is a very interesting property of this point A. Let's drop vertical lines from point A and from the landing point, and we find that these 2 horizontal distances happen to be the same. Also, for a projectile, we know that the horizontal component of velocity is constant, which means that the time taken to cover this distance would be identical to the time taken to cover this distance in the x direction. So let's slide a ball along the x direction with a constant speed. So we slide this blue ball at a constant speed of v0 cos of alpha plus beta, and it would cover both halves of the total distance in equal amounts of time. And you can see that the blue ball is just like a vertical projection on the ground of the projectile, since they cover equal displacements along the x-axis in equal amounts of time. This, in other words, would mean that the time taken from the launch point to A would be the same as the time taken from A to the landing point. There is a mathematical proof for this, but that is beyond the scope of this lesson. So even though the trajectory appears asymmetric about A, in terms of the time of flight, A happens to be midway. Now the total time of flight we had computed as 2v0 sine alpha over g cos beta. The time from the launch point to A would be half of that, so v0 sine alpha over g cos beta, and it would be the same from A to the landing point. So if the projectile took 10 seconds to go from launch all the way to landing, then it would take 5 seconds from launch to point A. So half the total time of the flight, regardless of the speed, regardless of the launch angle alpha. So on an incline, the projectile takes half the total time of flight to get to the position of highest displacement from the plane of the incline, and this is not very obvious, especially with the trajectory being asymmetric about A. This property is sometimes very useful in solving problems related to the maximum height of a projectile, and we will make use of this property to compute the maximum height h of a projectile perpendicular to the incline in the next lesson. The maximum height of a projectile launched on an incline is measured perpendicular to the plane of the incline. Even though the trajectory of the projectile is not symmetric about the maximum height point, the time taken by the projectile from the launch to the highest point is the same as the time taken from the highest point to the landing point.